In the previous videos, you assessed what data you have and how to use that information to establish a baseline. Now that you've established a baseline, we'll look at the savings mechanisms that cause your compressed air system to use less energy when you implement energy conservation measures. This will help ensure that you only apply calculations, tools, or rules of thumb that are based on valid assumptions about how your system operates. Let's start by looking at the three savings mechanisms for compressed air systems: reduced flow, reduced pressure, and improved compressor efficiency. There's also the potential for heat recovery from the compressor, but as this is not directly part of compressed air operations, we won't cover it here. Reducing flow refers to energy conservation measures that reduce how much compressed air is used. This includes repairing leaks, using engineered nozzles, eliminating inappropriate uses, or other flow reduction measures. Reduced flow impacts the control signal to the compressor, which then reduces the amount of compressed air produced by the air compressor. Your type of compressor and control system will determine how this reduced air production will impact energy consumption. For example, if your compressor is controlled by a variable frequency drive, energy consumption will decrease almost in proportion to the reduction in flow. However, if your compressor is controlled by load-unload or inlet valve modulation, you won't achieve the same level of energy savings. Reducing pressure means either reducing the discharge pressure of the air compressor or reducing the pressure to specific end uses. Reducing the discharge pressure of the air compressor has two impacts. First, the compressor doesn't need to work as hard to compress the air. This reduces the full load power. Second, the reduced pressure throughout the system reduces the volume of air consumed, at least in the sections of the system where the pressure is reduced. Lower pressure means less air is forced through the openings. This excess flow due to higher than necessary pressure is called artificial demand, and reducing the artificial demand has a similar impact as reducing flow. Reducing pressure at end uses using pressure control valves or storage receivers does not impact how hard the compressor has to work to compress the air, since it doesn't change the discharge pressure, but it does reduce artificial demand downstream of the pressure reduction. The third savings mechanism, improved compressor efficiency, typically involves upgrading the compressor or the compressor controls. Upgrading to a more efficient compressor will shift the compressor curve down if the new compressor has a lower full load power. Improving your control strategy will change the compressor curve to require less power at part load. Understanding these three savings mechanisms and how changes to your compressed air system will affect your baseline energy consumption will help you make accurate assumptions in your calculations and avoid estimated savings that don't reflect reality. The last step is to identify appropriate savings calculations. In the next video, we'll apply what we've covered so far to select a savings calculation approach that's appropriate for your system and energy conservation measure.